Question 4 here, we have the fourth in a row of statistics and data handling questions in that paper. Now this one says that 3 schools wrote the term test. All 3 schools have the same number of learners, which is quite important. And here they give us a table, school A, school B and school C, their respective means and standard deviations. And then they also drew us a graph of the distributions of each of these schools. Okay, now let's see what the questions are. 4.1. In which school is the majority of the results more widely spread around the mean? So that means there's a higher standard deviation, a greater variance. So we just look for the school that has the greatest standard deviation. And we see that's school B. So the answer here would just be school B, because your reason would be it has the highest standard deviation. As easy as that. In 4.2 they ask us, what is the difference in the spread around the respective means of A and C? So between A and C, what's the difference in the spread around the means? So the spread around the means basically tells us what the standard deviation is. Part of the definition of a standard deviation or a variance. So we look at A and C, the spread around the mean of A and C are the same. So 2.3, 2.3, what's the difference between them? Nothing. There is no difference, and we could say the reason is the standard deviation of A is equal to the standard deviation of C. Okay, question 4.3. Explain how the marks of school A must be adjusted to match that of school C. So let's see what the differences are between the schools currently. Currently school A and C, they have different means, but they've got the same standard deviation. Okay, so all we need to do is get the means the same. So how will we get the mean of school A to match that of school C? Well, at the moment it's 9.8, so if we add 5 marks to each student, then the average would increase by 5 marks and be equal to that. But we haven't shifted the standard deviation at all because we adjusted each mark by the same value. So that won't change the standard deviation. Okay, so all we need to do here to school A, to get it the same as school C, is we need to increase each mark, or each student's mark in school A by 5 marks. That's it. Question 4.4. If each mark in school C is lowered by 10%, now notice not by 10 marks but by 10%, explain the effect it will have on the mean and the standard deviation of this school. Okay, so school C, if we decrease the mean if we decrease each mark by 10%, the whole mean will decrease by 10% as well. So if the mean, how will that be affected? Well, that'll decrease by 10%. And the standard deviation, you might ask yourself, what will happen to that? Well, it turns out the standard deviation will also decrease by 10%. Okay, and now that's all you need. This is only a 2-mark question, but let's just go over the explanation of why that will happen. Let's look at the equation of how to calculate the mean of a function. The mean is equal to the sum from I equals 1 to n. Let me just write it a bit bigger, sorry. The mean is equal to the sum from I equals 1 to n of xi, and that all divided by n. So that just says you add all the marks up from the first mark to the last mark, and then you divide it by the number of marks there are. Okay, so that's the mean. But now if we subtract 10% from each mark, then if we subtract 10% from each x, then each x would now be 0.9x. So the mean after we've subtracted 10% would now become the sum from I equals 1 to n of 0.9 xi divided by n. What can we do now? Well, we can factor out that 0.9, and we can say this is equal to 0.9 times the sum from I equals 1 to n of xi divided by n. So we'll see that this part here is exactly the same as the original mean, but it's only 9/10 of the original mean. So the mean has decreased by 10% from here to here. Now let's look at standard deviation. The definition of standard deviation, the formula for calculating that, is standard deviation is equal to big square root sign, the sum from I equals 1 to n of xi minus x bar squared divided by n. Okay, so this just says, the idea here just says what is the average distance between each xi and the mean. Okay, now if we subtract 10% from the standard deviation, we can do the same thing as we did above. So the new standard deviation equation would now be big square root sign again of the summation from I equals 1 to n of 0.9 xi minus, and we know the mean would now be 9/10 of the original mean as well, squared over n. Now we can factor out the 0.9, so that's equal to the summation from I equals 1 to n of, if we factor out the 0.9, let's just write it all out. So that's 0.9 and xi minus x bar all squared. Okay, so now if we factor out this 0.9, we'll see it's be 0.9 squared. Oh, let me just write the full part of the equation. So we factored out that 0.9, but now the 0.9 has to be factored out of the little square brackets as well. So that'll become 0.9 squared. Summation from I equals 1 to n of 0.9 squared times xi minus x prime x bar squared over n square root. And one final piece, we'll factor out the 0.9 squared. So 0.9 squared, taking it outside the square root sign, will just make it 0.9. So we've got 0.9, and then we have the square root of the sum from I equals 1 to n of xi minus x bar squared over n. And again, we can see the original standard deviation here is the same as this, but with the 0.9 factored out. So this is 10% less than that. And that's your reason for why number 4.4 was true.